Hello Physical Science, this is Mr. B. We're continuing on with section 1. Remember, it's titled Ionic Bonding. And the main thing that we really discussed in the last video was the electron dot diagram and how it represents the number of valence electrons with this element symbol in the middle. And it also will kind of give us an indication of which elements are going to be more reactive, because remember we said that all elements want to achieve an electron configuration similar to those of the noble gases, which has an outer shell that's completely filled. Their valence electrons has 8 total. So now we are going to talk about how other atoms what other atoms actually have to do to obtain that stable electron configuration, because we ended saying that that's their goal. That's what other atoms want. They want to have that stable electron configuration like the noble gases. So what steps do they have to go through to actually obtain that? So first is, what is one way in which elements can achieve stable electron configurations, which is what I just said. So some of them achieve stable electron configurations through the transfer of electrons between atoms. So that's pretty simple, actually. So if I have a stable, or if I'm almost stable, maybe I can grab one electron from one other element and that'll make me stable. It might make them a little more stable too. So they could just transfer electrons between themselves. So a couple examples would be a chlorine atom has 1 electron fewer than an argon atom, so adding 1 electron would give chlorine a stable configuration. And then kind of on the opposite side of that, a sodium atom has 1 more electron than a neon atom, so removing that 1 electron would give sodium a stable configuration. So remember, sodium is an alkali metal in the 1A group, so it's very reactive. So if you just take that 1 from its outer shell, that means its next shell would be completely filled. So that's what that's why if you take 1 away from a sodium, it will make it more stable. But we'll take a look. I know that kind of sounds confusing just by looking at it, but we'll actually do an example of what that is actually trying to tell us, and it'll make more sense. We'll actually take a look at the electron dot diagrams. So this is really important here, so make sure you're listening and paying attention to this. So when sodium reacts with chlorine, an electron is transferred from each sodium atom to a chlorine atom. Each atom ends up with a more stable electron arrangement than it had before the transfer. So this is our example. This is what we're going to really focus on down here. So we have sodium. It has 1 valence electron. Chlorine has 7. So what it's going to do, in order to achieve a stable configuration, this sodium electron is going to want to jump over here and join this chlorine, over here. Because if you look, chlorine's really close to being stable, so it's really going to want that 1 electron from sodium. And you know what? If sodium gives up that electron, it's going to become more stable itself. So it's a win-win situation for both atoms involved here. So this sodium is going to basically transfer its electron right over there to chlorine, and then anytime you see this arrow, that's just basically like an equal sign, so it basically means, and as a result of this reaction, so it's basically means an equal sign. So after that occurs, we now have sodium with a plus, and we have chlorine with a full outer shell filled with 8 valence electrons, and it now has a minus. And we're going to talk about the reason why it has a minus more in depth here in a second, but hopefully remember, an electron has a negative charge, so now sodium gets rid of one of its electrons, so now it's going to have a net positive charge because that is 1 less electron. Chlorine gained an electron, so now it's going to have a minus sign. So that's where the plus and minus actually come from, but we'll get into that in a second. So that's kind of confusing, because usually you think if you gain something that makes you positive, but when we're talking about gaining electrons, it means you're going to be gaining a negative charge. When you lose an electron, that means you have 1 more proton now than electron, so you're going to have a positive charge. And so then now this is what I just said, but we're going to hear it again. When an atom gains or loses an electron, the number of protons is no longer equal to the number of electrons. So in a normal atom, again, the number of protons and number of electrons is always equal to one another, so there's really no charge on a standard atom that's just floating around. However, if they gain or lose an electron now, we now have again, now we're going to have a charge. The charge is not going to be balanced. So the charge on the atom is not balanced, and therefore the atom is not neutral. And so when an atom is not neutral, we have a special name for it, and that is an ion. So I would make sure I wrote down what an ion is, and it is an atom that has a net positive or negative electric charge. So because it either gains or loses an electron, it is now known as an ion because it has a charge associated with it, either positive or negative. And the charge of an ion, or charge on an ion, is represented by a plus or a minus sign like we just saw right here. So now, instead of just regular sodium and regular chlorine, we have a sodium ion and a chlorine ion. And how we can tell the difference between a plus and a minus, so we're going to start with chlorine, which had the minus. So the ion that forms when a chlorine atom gains an electron has 17 protons and 18 electrons. So hopefully you can tell now that that is one more electron than proton. So now the ion has a charge of -1, or they write the 1 and then the minus. So the ion has a charge of 1 minus. And the symbol now, instead of just Cl, is right here. We could write Cl1 minus, but when it's just a 1, we can kind of assume that that 1 is there, or just write Cl minus for short. And an ion with a negative charge now has an even more specific name called an anion. So I would make sure I wrote this down, that an anion is a negative charged ion. And anions like Cl minus are named by using part of the element name plus the suffix IDE. So that is where like the oxide came from, if you remember from our first video. So if you are an anion, you have "ide" at the end. That's one way you can tell that you have an anion. So thus Cl minus is called a chloride ion. It's not called a chlorine ion anymore. Because it is a negative charge associated with it, we add the suffix IDE on the end. So now we have chloride ion. So hopefully that makes sense. Again, I know that's a lot. Anion, negative charge, written just with a minus sign because it has one more electron than protons. And when we actually write the names for them, the names change a little bit when they have an extra electron. And now we write IDE at the end. So we have a chloride ion. And then on the other side of that, now we had sodium, and sodium is basically going to be just the opposite. Sodium now has 11 protons and it only has 10 electrons, so now it has a charge of a 1 plus, and the symbol now is Na1 plus, or just simply Na plus for short. And now we have a new name for a positively charged ion, and that is a cation. So I'd make sure I wrote that down. An ion with a positive charge is called a cation, and it uses the element name as in the sodium ion. So we do not change the name at all when it has a positive charge associated with it. If it's an anion, has a negative charge, it gets the IDE added. If it's a positive charge, it's a cation, and we do not change the name or whatsoever. We just use the name of the original element. And again, positive charge for a cation, negative charge for an anion. And now, actually, the formation of our ionic bonds. So a particle with a negative charge will, in fact, attract a particle with a positive charge. So that's pretty much basics. Opposites attract there. We already talked about that. And a chemical bond is the force that holds atoms or ions together as a unit. So this is kind of the big general term for a force that holds atoms or ions together. And then the specific bond that we're talking about, an ionic bond, it's a force that holds cations and anions together. And it will only form when electrons are transferred from one atom to another. So chemical bond, all of what we're going to talk about from now on is pretty much going to fall under as an example of a chemical bond. Ionic bond is a specific example that occurs just between cations and anions, and they occur when electrons are transferred from one atom to another. And in order for those electrons to be transferred, it's not just like, okay, no matter what, here you can take my electron. There actually is some rules that they kind of have to follow, and that is something that's kind of determined by what's called ionization energy. And and what this means is that when cations form, when electrons gain enough energy to escape from their atoms, the energy allows electrons to overcome the attraction of the protons in the nucleus. So the amount of energy used to remove an electron is called the ionization energy, and the lower the ionization energy, the easier it is to remove an electron from an atom. So ionization energy is basically going to determine how easy it is for an atom to give up an electron. And so if we look over here on the left, moving from left to right, it's going to get increased. So our 1A elements, they're going to really easily give up an they're going to give up one of their electrons really easy because it'll give them a stable electron configuration. Over here, the noble gases over here, they are not going to ever want to give up one of their electrons because they already have a stable configuration, so it really doesn't make as much sense for them. So we will talk more specific examples in class. Just know ionization energy is the energy required for the electrons to actually escape from the pole of their protons and then form an ionic bond with another ion. So that is it for this video. Let me know if you have any questions.